As an example of a more involved surface parametrization problem, I thought we would look at one of the problems from the textbook, say, for example, number 4. Okay, and they were asking us to come up with a description, a formulaic description of the part of the cone given by that formula for z right here, between the planes z is equal to 2 and z is equal to 4. So it may help us to get an idea of what this surfaces look like. So z is equal to, given by the formula, 2 square root x squared plus y squared. That's the equation of a cone. Okay, but that cone is between z is equal to 2 and z is equal to 4. Okay, and you could plot this for, say, x going from, say, negative, I don't know, negative 4 to 4. Y going from negative 4 to 4. Couldn't hurt to pick whatever. Z going from 0 at least up to 4, so let's go to 5 perhaps. Okay. And let's look at a contour plot 3D of all these different functions. And it should look like a cone with 2 planes chopping through it. And there we have the cone, and there we have the 2 planes. Okay. We'll go ahead and make this, let's make each of those a little opaque. So we have these 3 surfaces, and I think the part of the cone that we're trying to describe is the part that is between those 2 planes. So it should have a flat bottom, this cone, the surface of the cone, and it shouldn't go higher than that green plane right there. So to describe that region, it's going to be helpful if we look at the parametric surface of it. Okay, the parametric description actually will be the best way to go. Okay, one thing to note here is that when you're looking at it, right, we can see that those 2 planes chop the surface into 2 different circles. So maybe this is a bit, let me make this a little less, it's a bit too transparent. So can you see the 2 circles created? There's this kind of weird green one right here where the plane cuts through, and then there's a smaller circle. Okay, so the values that we're looking for, the radii of those 2 circles changes. And we're getting circular regions in the xy plane, which tells me that maybe we should try to do a polar coordinates description of this surface, which means that x and y are going to be functions u cosine of v, u sine of v, where u is equal to the radius variable and v is equal to the angle variable. And because we're going all the way around, when we looked at this region, right, it's the cone is going, it's a full cone. Okay, we just don't know what the radius of these circles go from and to, and we also don't know what the z entry of the vector valued function is. But we kind of do know the z value because they said z was 2 times the square root of x squared plus y squared. But this is the z entry of the vector field, and x is equal to u cosine of v and y is u sine of v, so we should get 2 square root of u squared for the z entry. Okay. And when z is equal to 2, z is also equal to 2 square root of x squared plus y squared, which says that 2 is 2 square root of x squared plus y squared, which says that 1 is equal to x squared plus y squared, which says that the circle, that blue circle down there that is cutting into the cone, is a circle of radius 1, which means that our radius should go from 1, our radius variable should go from 1 up to, when z is equal to 4, z is also equal to 2 square root of x squared plus y squared, which will say that 2 is equal to the square root of x squared plus y squared, which is a circle then of radius 2. So our radius should go from 1 to 2. And now we have a complete description of that surface. We have filled in each of the entries of the vector valued function. We filled in x as a function of u and v. We have filled in y as a function of u and v. And we filled in z as a function of u and v. And we've also got a good handle on what the variables represent, the radius and the angle, and we have described the parameter values for u and v that describe that surface. So all that remains now is just to check that we've got the right answer. There's the first plot. And now the second plot is going to be a parametric plot 3D, where the first entry is u times the cosine of v, y is u times the sine of v, so basically doing polar coordinates. Z is equal to 2 times u, and u goes from 1 to 2, and v goes from 0 to 2 pi. V goes from 0 to 2 pi. Okay. And when we put these two plots together, we should see the part of the cone highlighted is only the part that is between those two planes. So can you see it? There is the only part that we have found in our parametric formula. Okay. So I think we have described the region that they were asking for in this problem. And the rest of the problems are similar to this. It's just kind of getting an idea of the surface and kind of mixing polar coordinates and kind of cylindrical coordinates together, and maybe doing a Monge parametrization as we indicated in some of the introductory examples. So the rest just takes practice, and there's some homework problems and some additional problems to try, 1 through 3, for example, on the right here. You could try to compute those problems, or describing part of the problems using partly spherical coordinates, or maybe even describing some portions of a plane that's trapped in between a part of a cylinder, for example, on some of these, 11 and 12. Okay, so 9 and 10, maybe Monge parametrization would come in handy. So we'll look at some more examples in class.